Hello all, my name is Ashutosh. I'm a teacher by profession. My mission is to impart quality education for all. For that purpose, I'm creating these videos. If you appreciate my work, then please do like my video and subscribe my channel so that I could get the motivation to prepare more videos.
Anyways, today in this particular lecture, we will going to discuss about multiple access techniques. So these are the outlines. We're going to start up with the introduction. Then we will going to describe about multiple access environment. What do we mean by multiple access environment? Then we will going to describe duplexing and its types. That is, what do we mean by full duplexing mode of communication, where bidirectional simultaneous communication would have been possible, and its various types such as frequency division duplexing and your time division duplexing. Then we will going to discuss a classification of multiple access techniques in terms of contention based protocol and contention free protocol. Since in our syllabus we only have conflict free protocols, so we will confine our discussion on conflict free protocols only, such as your FDMA, TDMA, hybrid FDMA, TDMA, CDMA and SDMA. Although we have to discuss all those protocols one by one, but in this particular lecture we will only discuss about your frequency division multiple access. So we will going to cover up complete specifications of frequency division multiple access, various advantages and disadvantages associated with the FDMA and the application areas of FDMA. So in a wireless environment where most of the mobile users are trying to transmit their signal, it is difficult to provide interference free transmission. So obviously if we are talking about a common medium where multiple signals are present at a time, so it might be very difficult to provide interference free transmissions, such that we know that interference will going to happen when two or more signals having the same frequency and they are present at the same time in the same medium. Anyhow they will going to overlap with each other, due to which their signal strength will get abruptly changed. That is, at certain places their amplitude gets added up and at certain places their amplitude gets subtracted. So this is an observed phenomena which is known as your interference. So obviously if we are talking about common medium and we are talking about there are multiple users present in the same scenario and they are transmitting over some frequency ranges, then obviously interference might get alter our transmission. So how can we provide interference free transmission? So the solution is multiple access techniques. So what do you mean by multiple access techniques? Before we go into the greater detail about multiple access techniques, let us discuss some of the areas where multiple access techniques are used. It would mainly be used in your satellite network, mobile communication network and acoustic network, or we could say your underwater communication systems. These are certain areas or examples where multiple access techniques are being used. The main idea is to provide the intercommunication of multiple users which are present in the common medium at the same time in the interference free environment. So obviously the common medium we are talking about, it could be your uplink in the satellite communication system, or we could say that wireless medium where multiple satellites are transmitting and receiving the signals, and that common medium could be your cable if you are talking about wired systems or any frequency band. So before we discuss about various multiple access techniques and how do they actually work, let us understand about multiple access environment, what it is. So obviously in order to understand the multiple access environment, we could take the example of any of the above examples that we have given. That is, either we could consider our satellite communication system, our wired or wireless communication systems, but since we are dealing with wireless communication systems, so we will be only focusing over our mobile communication system. So this particular figure is showing the multiple access environment. Here we will be having a base station whose coverage would have been called as your cell, and there are multiple mobile subscribers which are trying to exchange their information with the help of these base stations. These red lines are basically representing a kind of links. Through these links our mobile users will try to exchange their information with the base station. So obviously we could say that there is a base station and there is a common environment in which multiple users or mobile users are competing for their information exchange. So they are basically competing in order to get the link so that they could be in a state to transmit their information as well as receive their information from the base station. So obviously all of the mobile users are dependent for their communication system over this base station. So obviously all these mobile stations want to transmit their information as well as receive their information in the common medium. So wireless multiple access environment basically describing a situation where multiple mobile users are competing to take the access of the link in the common medium in order to inter-exchange their information, obviously in interference limited environment. So if we talk about our multiple access techniques, so these are specific techniques which can be implemented in our multiple access environment in order to provide the interference free environment for inter exchange of the information among the users. So before we will going to discuss the classification of multiple access techniques, let us discuss about duplexing and its types. So as we had already discussed that in our multiple access environment, our mobile subscribers want to transmit as well as receive their information simultaneously. So if we talking about the modes of communication, we could classify the communication between any two entities on the basis of signaling direction. That is, suppose there is a base station and there is a mobile station. By direction of signaling, we mean that whether there exists a flow of signal from base station to mobile station. So if only single directional communication is possible, that is, information can only be passed from base station to this mobile station, that is called simplex sort of communication or simplex communication. And if it is possible bidirectional communication, that is, signal can transmit from base station to mobile station as well as mobile station to base station, but one directional transmission could be possible at a time, then we will going to call them as a half duplex mode of communication. And when simultaneous transmission as well as reception is possible between the entities, then we will going to call them as your full duplex mode of communication. So in our mobile communication scenario, user demands simultaneous transmission as well as reception of the signal. So this full mode of duplexing would have been implemented with the help of duplexers, and those duplexers would have been implemented with the help of two techniques, that is your FDD and TDD. So for voice or data communication, we must assure two-way communication, that is, both the direction the communication is possible. So duplexing is somewhat where it is possible to talk as well as listen simultaneously. It may be done using frequency or time domain techniques. So these are the techniques about which I am talking about. So forward band provides traffic from the base station to mobile station. So when we are discussing about our cellular communication, we have described two sort of links, that is your forward as well as reverse link, where we have described that in forward band transmission there exists a signaling flow or traffic from base station to the mobile station, whereas in the reverse link vice versa, that is, our signaling will going to pass from mobile station to the base station. So forward link could have also been called as your downlink, as well as reverse link also being called as your uplink. So you could say that when you are transmitting your signal from mobile station to base station, you are uplinking your signal, and when you are receiving the signal from the base station, then you are downlinking. That particular link is called the downlink. So this is what we have already discussed. Reverse band provides the traffic from the mobile station to the base station. So this duplexing would have been performed with the help of two mechanisms, that is your frequency division duplexing and your time division duplexing. So what we will going to do in our frequency division duplexing is uplink or downlink communications are separated in the frequency domain by assigning two different frequencies. So we are providing two different frequency bands, one for uplink mode of transmission and second one is for downlink mode of transmission. So second technique is your time division duplexing. So what we will going to do in our time division duplexing is we are allowing our transmission, that is your uplink as well as the downlinking, over the same frequency bands, but we are providing different time slots for uplink as well as downlinking, and these time slots are too small to be perceived by any user. So we are just having the feel of that we are continuously transmitting as well as receiving the signal. So now we will going to discuss about multiple access techniques. So what are they? Multiple access schemes allow many mobile users to share a finite amount of radio spectrum in efficient manner. So obviously we are talking about a common radio spectrum. So how we will going to use that common radio spectrum in an efficient manner so that the requirement of communication of all the mobile users would have been accomplished in the interference limited environment. So depending upon whether there exists any conflict or not among the various users, we can classify multiple access techniques into two types. So what do we mean by conflict? By conflict, we mean that simultaneously when two or more users will going to transmit their information might get garbled up due to the interference. We can classify our multiple access techniques into two types. Number one is your contention based, or we could say that conflicting. The word of conflicting we have already described. And second one is your contentionless or conflict free. So by contentionless or conflict free, we mean that there will not going to exist any sort of collision or conflict among any two users, or we could say that the signal exchange will going to take place in our interference free environment. So some of the examples of our contention based or conflicting protocols are Aloha, slotted Aloha, persistent P Aloha, etc. But now in this particular lecture, we will only going to discuss about contentionless or conflict free protocols. So conflict-free multiple access techniques can be implemented with the help of channelization. So by channelization, we mean that how we will going to divide our common physical medium so that we can provide interference-free environment for the multiple users which are using that common channel. There are basically four dimensions by which we can divide our channel so that the signal will not going to interfere with each other. These four signal dimensions are your frequency, time, code, and space. So what do we be going to do in our channelization process is we will going to divide our complete bigger channel into smaller portions of such elements or signaling units such as its frequency, time, code, and space, and we will going to provide a smaller portion to each and individual user for their information exchange. So if multiple users are exploiting those channel units for their signal transmission, so their signal will not going to garble or their signal will not going to overlap with each other, or we could say that we have implemented interference free environment for signal transmission. So examples of channelization are your frequency division multiple access, your time division multiple access. Third one is your spread spectrum multiple access. The example of spread spectrum multiple access is your code division multiple access, and last one is your space division multiple access. So in our frequency division multiple access, we are basically dividing the frequencies into multiple subbands, whereas in the time division multiplexing, we will going to divide the complete channel into different time slots, and in the code division multiple access, we are dividing our common medium into different orthogonal codes, and in the space division multiple access environment, we are dividing the common medium into several smaller spaces. So now we're going to start up with your FDMA. It is your frequency division multiple access. So what we're going to do in our frequency division multiple access is we will going to divide the complete frequency band, or we could say that the channel spectrum, into number of non-overlapping frequency bands with some guard band. So we will going to divide our complete frequency spectrum into subbands which are non-overlapping, and we will also providing certain spaces in terms of frequencies between any two frequency subbands where we will not going to transmit any amount of information. So these particular frequency ranges over which we are not at all transmitting any of the information would have been called as your guard band. The use of our guard band is it will basically going to prevent the interference. So each station is assigned a fixed frequency band. Then we will going to provide each of the user to a fixed frequency band. So here by station we mean a user. Then each channel occupies the same frequency band all the time. So whatever frequency band would have been assigned to an individual user, it will going to use the same frequency band all the time for its transmission or for its communication purpose. So receiver should tune to the same frequency band to receive the signal. So obviously in order to receive the signal generated by the transmitter, receiver should tune over the same frequency band over which transmitter is transmitting so that it could properly receive the signal. So the example would have been considered as your FM broadcast communication system, where we have to tune in over certain frequency bands such as 91.1 or 93.5 in order to extract that information signal. So this particular figure is showing the working of frequency division multiple access. So this particular figure is showing the three signal dimensions, that is your frequency, code and time. So in frequency division multiplexing, what we have to do is we have to divide our available frequency bands into multiple sub bands. So in this particular example, we are assuming that there are existing 6 number of users, that is your K1, K2, K3, K4, K5 and K6. So we have divided our complete available spectrum or frequency band into 6 equal number of parts, and we had also provided a separation between any two consecutive users frequency subband. So here in this particular figure, it is quite clear that for all the users, that is your K1, K2 up to K6, only a smaller portion of frequency band is available for all the users for the complete duration of time. So this is what we are actually doing in your frequency division multiple access techniques. You can correlate it with your frequency division multiplexing. So when we will going to combine our signal to use the common medium, in that particular case, that process would have been called as your frequency division multiplexing. And when we will going to try to access the common medium in order to fetch our own information, then that particular scenario is being called as your frequency division multiple access technique. So in broader context, you could also say that multiple access techniques would have been implemented in conjunction with multiplexing. It can be used for both, that is analog as well as the digital transmissions. So I mean, for analog as well as digital, both type of transmission systems can use frequency division multiple access. So this particular figure is showing the frequency division multiple access scenario. Here we have divided our complete frequency ranges into n number of sub bands, that is 1, 2, 3 up to n, and we had also provided a guard band between any two consecutive sub bands. So as we had already discussed, that guard band is the range of frequencies where we are not at all transmitting any sort of information signal. These are just for guarding purpose, so that we could prevent the interference among the users. So here our complete frequency band, which is denoted by your BT, that is your total bandwidth, would have been divided into n number of equal subparts, where each subpart is having the bandwidth of BC, and any two sub bands would have been separated with guard band, which is denoted by your B guard. So about B guard, we had already said that these are the frequency bands which are left idle, that is we will not going to use them for signal transmission purpose in order to avoid the interference. So the total number of channels in FDMA can be evaluated as n is equal to BT minus 2 B guard divided by BC. So where n is total number of channels, BT is the total bandwidth, BC is the channel bandwidth, and B guard is the guard band. So obviously, if we need to find out that with the help of complete frequency band BT, how many number of users can use that particular frequency band in FDMA, so we could calculate with this particular numerical relationship, that is number of users will be equal to total frequency band minus 2 times of guard frequency band divided by BC, which is nothing but your channel bandwidth or sub channel bandwidth. So the advantages of FDMA systems are all the users can transmit their information all the time without waiting for their turn. This is what we had already seen from the last figure, where the sub band frequencies are available for the individual users, that is your K1, K2 up to K6. Those sub band frequencies will be available to all the users all the time, that is whenever they want they can transmit their information. Second advantage is no dynamic coordination is required. Since we have fixed the sub-carrier frequencies to each and individual users, so there will be no dynamic coordination required. I mean, if there is a reservation for each and every user that which particular frequency will have been accessed by that particular user, there will be no requirement of any sort of dynamic coordination, since we have implemented a static system. So the disadvantages of FDMA are it is inflexible and inefficient if channel load is dynamic and uneven. So obviously, if we have implemented an static mechanism to access or share the medium, in that essence it is not flexible, it has become static, and the functionality would become inefficient if the user is generating a traffic which is uneven. That is, at certain time it is generating more amount of information, and at certain instant it is generating lower amount of information, and even there are some times where it is not at all generating any sort of information. So during the time when the user is not at all generating any sort of information, then also we have provided those frequency bands to that user, which is inefficient utilization of available spectrum. Adjacent channel interference is present in spite of providing guard bands. So although we are providing guard bands in order to avoid the interference, but then also adjacent channel interference present in our FDMA systems due to the non-ideal characteristics of the filters. So the application of FDMA are: each channel gets a band or range of frequencies used in traditional radio, TV, etc. So these are some of the applications where FDMA systems would have been used. Traditional radio example we had already given. Television broadcast is also one of the example of your FDMA systems. So FDMA is also present in various wireless communication standards such as your AMPS, CT2, DECT, etc. So where this AMPS, advanced mobile phone systems, is a 1G standard for your cellular communication systems, whereas cordless telephony 2 and digitally enhanced cordless telephony are the examples of your second generation systems. So hopefully you will get the insight about your multiple access environment, as well as you have also understood the concepts of frequency division multiple access technique. In case of any doubt, you can ask me in the comment section and I will try to solve them. These are the references. Thank you very much for your patient hearing.